Hi students, this is Anitara, Geochemistry Mentor. In this session, we shall see some numericals on osmotic pressure. Actually, this osmotic pressure comes under colligative properties. So now you all know that colligative properties depends upon the number of solute particles. Is it not? It depends upon the number of solute particles and it doesn't depend upon the chemical nature of this solute particles. Actually, what is osmotic pressure? See, if you want to understand osmotic pressure, you should know what is osmosis. Okay. So let us consider, see this picture. Let us consider two solutions. One is a dilute solution, another one is a concentrated solution. Okay. See, this is a concentrated solution, right? Let me write concentrated, and this is a dilute solution. Now what happens, we are separating these two solutions by means of a semi-permeable membrane. This membrane will be allowing only one particular component through its membrane, right? So in order to maintain an equilibrium, what happens is the solvent molecules will start moving to the concentrated side from the dilute side. This process is called as osmosis. So during this process, a pressure will be involved, and that pressure is called as osmotic pressure. Okay. Normally, this osmotic pressure is represented by the symbol pi. Okay. This osmotic pressure can be used to calculate the concentration of solutions, right? Concentration of solutions, and also this all the colligative properties like elevation of boiling point, depression of freezing point, then relative lowering of vapor pressure, and including this osmotic pressure will be utilized to calculate the molecular mass of some substances. Specifically, this osmotic pressure is used to calculate the molecular weight of protein. Okay, so it is used to calculate the molecular weight of proteins and then polymers, right? And also certain macromolecules, okay? Because other colligative properties are not used to check the molecular weight of these compounds because they may undergo denaturation, right? So macromolecules, you can calculate the molecular weight of these macromolecules also, right? So let us see some formulas which we are going to use in this numericals, right? Let us see the formula, students. The first formula is pi is equal to CRT. We all know that pi represents osmotic pressure, okay? And C is the concentration of the solution. Here C represents a molarity, okay? Molarity. So molarity, which is equal to N by V. N is N2, that is number of moles of solute divided by volume of the solution, okay? Volume of the solution in liters, right? So molarity. R is equal to gas constant. It is 0.0821. It is a constant, right? And T represents temperature. Now there is another formula. Here we are making use of N by 2 by V in the place of C, okay? So pi is equal to N2 by V RT, where N2 is the number of moles of solute and V is the volume of solution in liters, right? In liters, okay? And the next formula is pi is equal to W2 by M2 RT by V. From where we are getting this M2 W2 by M2. See, this is nothing but N2 is equal to number of moles of the solute is equal to weight of the solute divided by molecular mass of the solute. So we are using this value W2 by M2 in this formula. So pi is equal to W2 by M2 into RT by V. Okay, where V represents the volume of solution in liters. Understood, students? Now we shall see the problems. Read the problem, students. Calculate the osmotic pressure of an NaCl solution at 25 degrees centigrade which contains 10 grams of NaCl. Molecular mass of NaCl is given as 58.5 dissolved in 100 meter cube of solution. See, in this problem they are asking you to calculate the osmotic pressure, okay? Let us write the data first. The given data, R value is 0.0821. Actually it is a constant, so we should know this one. And temperature is given as temperature is equal to 25 degrees centigrade, is it not? See, we should convert this 25 degrees centigrade to Kelvin scale. So we can add 273 with this, so that we will be getting 298 Kelvin, okay? And the next one is volume is also given. Volume is 100 meter cube. So 100 meter cube. Okay, and we should convert this 100 meter cube into liters. So we can 100 divided by 1000. So the value is 0.1 liters. Okay, and then W2 is given, that is weight of the solute is also given, that is equal to 10 grams. Okay, and then molecular mass is also given, molecular mass of M2, that is molecular mass of NaCl is given, that is 58.5. Okay, now we shall see the problem, how to find out osmotic pressure. So pi, let us write the formula first. Pi is equal to nRT by V. Okay, so we are in need of n. Actually n is not here, W2 is there, M2 is there, R is there, T is there, V is there, but we do not have this n. Okay, so we should calculate n. How to calculate n? N is the number of moles of solute. So N2 is equal to W2 by M2. Okay, so if you are substituting this value, you will be able to get N2. What is W2? 10. 10 divided by what is the molecular mass? 58.5. Okay, so it is 58.5. Now the value is 0.1709. Okay, now substitute this in the formula, students. Pi is equal to what is the n value? 0.1709, and then R value, it is 0.0821. Then temperature, it is 298 divided by what is V value? It is 0.1, right? So find out the answer. So it is 4.176 divided by 0.1. Okay, it is 41.76. Then you should write the unit also, it is ATM. You might have understood, students. We shall see the next problem. Read the problem, students. 1 liter aqueous solution of glucose, its molecular mass is 180 gram per mole, weighing 1010 gram, is found to record an osmotic pressure of 4.8 atm at 293 Kelvin. What is the molality of glucose solution? And the R value is also given. Okay, 0.0821. See, you are asked to calculate molality. Okay, first let us write the data given. You should do this problem carefully. Volume V is equal to, it is given 1 liter. Okay, and then weight of the solution, that is W is given, weight of the solution is given, that is 1010 gram. Okay, and then what else is given? Molecular mass, is it not? So molecular mass M2 is also given, that is 180, right? And then osmotic pressure is also given, pi is equal to 4.8. Okay, and then temperature it is what is the temperature given? Whether the temperature, yeah, it's given 293 Kelvin. So temperature is equal to 293 Kelvin. Okay, then R value is also given, R is equal to 0.0821, and you are asked to calculate molality, small m. Okay, how to do this problem? So volume given, weight of the solution is given. So let us write the formula for molality first. Okay, molality, that is m is equal to number of moles of solute, that is N2 divided by mass of solvent, not solution. Okay, mass of solvent in kgs, okay, that is W1. Understood? So now look at the formula, students. Number of moles of solute, check whether the number of moles of solute is given. No, it is not given. Mass of solvent in kilogram, W1 is given. No, it is not given. So you are supposed to calculate these two quantities, only then it's possible to find out molality. So let us do step by step. Okay, so the first step is step 1. We are supposed to calculate N2. We shall calculate N2. How to calculate N2? So we can calculate, I think we can calculate from the osmotic pressure. Since the osmotic pressure is given, it is possible to calculate the number of moles. So let us write the formula. Pi is equal to nRT by V. Okay, So all the values are given. R value is there, T value is there, V value is there, pi value is there. So directly you can substitute the values and find out the value. N2, this N is nothing but it is the number of moles of solute, that is N2. Okay. So N2 is equal to pi V by RT. Okay. Substitute the value, students. 4.80 pi value into V, what is V? 1 liter divided by RT, what is RT? 0.082 into temperature 293. Okay, all right. So what's the value? Find out. Simplify this one. 4.80 divided by 24.05. 0.05. Okay, 25.05. The answer is 0.199. So N2 is 0.199. So we have found out the number of moles of the solute now. Now next step is mass of the solvent in kilograms. Say how to calculate mass of the solvent, W1. We are in need of W1, but weight of the solution is given. So weight W is given. How to calculate weight of solution? Weight of solvent plus weight of solute. Okay, we are in need of weight of solvent. Okay, so how to calculate weight of solvent? W1 is equal to W minus W2. Okay, so this we can calculate. This one is available, W is available, that is 1010 grams, but we do not know W2. Only if we are calculating W2, it's possible to calculate the mass of the solvent in kilograms. Okay, so the second step is to calculate the weight of the solute. So we'll write the second step. Second step, weight of solute. We are in need of weight of solute. Okay, all right. So how to calculate weight of solute? See, there is a formula. Number of moles of the solute is equal to weight of the solute divided by molecular mass of the solute. Already we have found out N2. Is it not? N2 we know that is 0.199. And molecular mass also we know that is already given it in the problem. It is 180. So if we are substituting these two values, it's possible to calculate W2. So W2 is equal to N2 into M2. Okay, now substitute the value, students. W2 is equal to, what is N2? 0.199 into, what is M2? It is 180. So what's the answer? That is 35.82 grams. Understood, students? Now the third step. What is the third step? We are supposed to calculate the weight of the solvent, that is W1. Okay, weight of the solvent. How to calculate W1? So W1 is equal to W minus W2. Now substitute the values. What is W? It is 1010. Okay, 1010 minus what is W2? Here it is 35.82. Find out the answer. It is 974.18 grams, but we are in need of the mass of the solvent in kilograms, so we can convert this grams to kilograms. So it is 0.974 kgs. Okay, kg, right? Now next step, the final step, that we are going to calculate the molality. So that's our intention, right? Molality. How to calculate molality? From the number of moles of the solute divided by weight of the solvent, that is W1 in kilograms. Okay, so substitute the value, students. What is N2? It is 0.199 divided by what is W1? It is 0.974. So find out the answer. It is 0.204. Okay, M. So molality is, this is the answer, molality is 0.204 m. I hope you might have understood. We shall see the next problem. Read the next problem, students. An aqueous solution of a non-volatile and non-electrolytic substance boils at 100.5 degrees centigrade. Calculate the osmotic pressure of this solution at 27 degrees centigrade provided with Kb, that is Kb for water per 1000 gram is 0.50. So it's a different problem. Here the elevation of boiling, we want to calculate elevation of boiling point and then molality, and it's different. It's a different problem. So let us write the data first. Kb value is given. Okay, what is Kb? Ebullioscopy constant. Okay, ebullioscopy constant 0.50, and weight of the solvent is also given. Okay, weight of the solvent, that is W1 is equal to 1000 grams. Okay, and then a boiling point of the solution is also given. Okay, boiling point. Okay, an aqueous solution of non-volatile substance boils at 100.5 degrees centigrade. So Ts is given 100.5 degree centigrade. Okay, and then we obviously know the Tp. What is Tp here? Water, is it not? It's a pure solvent. Water is the pure solvent. So boiling point of water, obviously we know it is 100 degree centigrade. Okay, now we shall do the problem. Actually it is let us write the formula first. Delta, you are asked to calculate osmotic pressure. So osmotic pressure is, formula is pi is equal to nRT by V. Okay, this is the formula. You check anything is given here, R value, it's known, R is equal to 0.0821. Okay, alright. So we do not know V, we do not know N. Okay, so nothing we know, and temperature is given 27 degrees centigrade. Okay, but other thing N we do not know, so that should be calculated. How to calculate N? See, N can be calculated from this formula, since because this ebullioscopy constant and the boiling point of the solution and boiling point of the pure solvent is given. Let us go with this formula, that is delta Tb is equal to Kb into M. Okay, see Kb we know. Okay, Kb it's possible to calculate Kb, it's given in the problem itself. But if you are calculating this molality, it is possible to find out the number of moles, that is N. Okay, if you are calculating molality, it is possible to find out the number of moles. Okay, so first we should know delta Tb. How to calculate delta Tb? See, the delta Tb is equal to Ts minus Tp. These two values are given already. So what is Ts? 100.5. What is Tp? It is 100. So delta Tb is 0.5. Is it not? 0.5 degrees centigrade. Now substitute the value and find out the answer, students. Molality is equal to delta Tb divided by Kb. What is delta Tb? It is 0.5. Okay, what is Kb? It's already given 0.5. So the molality is 1 molal. Okay, see students, since the solution is 1 molal, number of moles will be equal to 1. Okay, since it is 1 molal solution. Okay, since it is 1 molal solution, number of moles will be equal to, that is N will be equal to 1. Okay, see now so we can substitute the N value, but we do not know V value, that is volume we do not know. So how to calculate volume now? So this one, so since it is a 1 molar solution, N is equal to 1. We are supposed to calculate the volume now. What is the formula for volume? How to calculate volume? See, volume is nothing but, actually density is equal to mass by volume. Okay, density is equal to mass by volume. Now we are in need of volume. So volume is equal to mass, okay, mass by density. Okay, see mass it is given, that is 1000 grams, right? 1000. Since it is a 1 molar solution, density will be equal to 1. So volume will be equal to 1000 ml. Okay, volume will be equal to 1000 ml. So 1000, if you are converting this to liters, in it will be 1 liter. Understood, students? Now we have calculated V also. So we know V, we know N, we know R, we know T. So now it's possible to calculate osmotic pressure. Pi is equal to nRT by V. Substitute the value, students. It is N is equal to 1 into 0.0821 into 27 degrees centigrade, is it not? So that should be converted to Kelvin scale is 300. We are converting 27 degrees centigrade to Kelvin scale. It's 300 divided by V1. Okay. So now the value is 24.63 atm. Okay. So we have found out the osmotic pressure. So hope you might have understood. We shall see the next problem. Read the problem, students. Calculate the molecular mass of urea in a solution made of 5 grams of urea in 100 meter cube of water whose osmotic pressure is 20.28 atm at 25 degrees centigrade. R is equal to 0.0821 liter per atm plus mole per Kelvin. Okay. So let us write down the data here. In this problem they are asking you to calculate the molecular mass. Okay. So R is equal to 0.0821, temperature T is equal to it's given as 25 degrees centigrade, so we are converting to Kelvin scale, that is 298 Kelvin, and V is equal to 100 meter cube. Okay, so we are converting that to liter, that is 0.1 L liter, and then osmotic pressure is 20.28 atm. And then weight of the solute is also given, that is urea's weight, that is W2 is equal to 5 grams. Okay. And you are asked to calculate M2, that is molecular mass of urea. Okay. So let us write down the formula. Pi is equal to nRT by V. Okay. So another formula also we know, that is N2. We are going to substitute the value of N2. N2 is equal to W2 by M2, is it not? W2 by N2, right? Now you can substitute the value of N2 here. Pi is equal to W2 by M2 into RT by V. Okay. Now substitute all the values, students. We are in need of M2, right? So M2 is equal to W2 RT by pi V. Okay. So what is the value of W2 here? 5. 5 into what is R? 0.082. What is T? It is 298 Kelvin divided by that is the osmotic pressure. It is 20.28 and volume is 0.1. Okay. So the answer is molecular mass, the M2 is equal to 60.2 gram per mole. It's a simple problem. So you can directly substitute all the values and find out the answer. Hope you might have understood all the problems, students. We shall see in the next session.